Welcome! Today, we'll be exploring the digital number system and understanding why it forms the core of digital technology. Number systems are at the heart of how computers and electronic devices work. They allow us to represent, process, and communicate data efficiently. Among the most important are the decimal, binary, octal, and hexadecimal systems. Mastering these allows you to perform conversions, calculations, and troubleshoot digital systems accurately. To truly grasp digital hardware and software, it's vital to understand number systems. Computers and devices speak numbers, and their instructions, memory addresses, and data all depend on these systems. If you don't understand how number systems work, digital design and programming can seem confusing and complicated. But once you do, everything from coding to electronic design becomes much clearer. A number system is a way of representing and working with numbers using different sets of symbols, which we call digits. Different systems use distinct sets of digits. The most common number systems are decimal, which is base 10, binary, base 2, octal, base 8, and hexadecimal, base 16. Let's start with the decimal system, which is the everyday system you're most familiar with. It uses 10 digits, from 0 to 9, and relies on the concept of positional value. The value of a digit depends on its position in the number. For example, the leftmost digit is the most significant, while the rightmost is the least significant. Each position in a decimal number represents a value 10 times greater than its neighbor to the right. The binary system, on the other hand, is the backbone of all digital devices. It uses only two digits, 0 and 1. This simplicity directly reflects the on and off states of electronic circuits. Binary makes error-free voltage detection easy and is perfectly suited for switches and logic circuits inside computers. For instance, the decimal number 5 is written as 101 in binary. Octal and hexadecimal systems act as convenient shortcuts for digital engineers. The octal system is base 8 and uses digits 0 through 7. Every 3 binary bits can be grouped as a single octal digit. For example, the binary number 101110 translates to 56 in octal. The hexadecimal system is base 16, using digits 0 to 9 and letters A to F. Every 4 binary bits become a single hexadecimal digit. For example, binary 11010111 is hex D7. These shortcuts make handling and reading long binary sequences much faster and clearer for anyone working with digital systems. Why should we learn to convert numbers between these systems? In programming, we often switch between human-friendly decimal numbers and machine-friendly binary. When debugging, error codes are often given in hexadecimal. In circuit design, using octal or hexadecimal simplifies complex binary wiring diagrams. For example, octal 237 is equal to decimal 159, and hexadecimal 24.6 converts to decimal 36.375. But how are binary values actually represented in hardware? In digital circuits, binary 1 typically corresponds to a voltage range from about 2V to 5V, while binary 0 is usually around 0V to 0.8V. There's a dead zone between 0.8V and 2V that's avoided to reduce errors. As technology advances, these voltage levels get lower, but the separation between high and low remains. This reliability is a big reason why digital systems are so robust compared to analog ones. Understanding number systems is essential for anyone working with logical circuits, programming at a low level, or debugging hardware. It helps bridge the gap between how humans and computers represent data. Knowing how to convert between systems makes learning digital theory much easier and helps in practical tasks like reading memory addresses or color codes in web design. Some frequently asked questions: why does digital technology rely on just 0 and 1? It's all about the easy reliability of binary states, on or off. To convert decimal numbers to binary, divide by 2 repeatedly and write down the remainders. Octal and hexadecimal are mainly used to shorten long strings of binary digits for things like error codes, memory addresses, and even color codes in web design. For practice, there are many online calculators and tutorials available. To wrap up, number systems form the foundation of all digital electronics. Understanding decimal, binary, octal, and hexadecimal is not just useful for calculations, it's key to design, coding, and debugging in digital technology. Once you've mastered this topic, much of digital theory becomes much more accessible and easy to learn.